Hello everyone, I'm Antonio Rios from University of Sevilla, and in the next minutes I'm going to explain the pure pursuit algorithm in this tutorial. Well, what is pure pursuit algorithm? The pure pursuit algorithm is a path tracking algorithm proposed by Craig Kuller in 1992. It is not something new, but it's very effective for path tracking. Here you can find the original technical note for its implementation. This algorithm can be used, for example, for autonomous vehicles or mobile robots. Here, in this recording, you can see a RC car which uses this algorithm to keep in the center of the path in the Formula 10 competition. Okay, but how does it work? Let's start by mentioning the assumption to consider. The path is a sequence of 2D waypoints that the car must follow, so the vehicle knows that sequence of waypoints. The car can localize itself in the waypoint system of reference. And finally, the main goal is to follow this waypoint in the look-ahead direction. So now we are going to move to explain a very simple geometrical interpretation on how to calculate the steering angle. So, if we know the position of the car in the 2D waypoint system of reference, and the origin of the car is at the center of the rear axle, the x-axis is the forward direction of the car, and the y is the right-hand coordinate. We can define a look-ahead distance, and this distance is a parameter of the algorithm and fetched to set forth a waypoint in the list in that radius. So, imagine that your goal waypoint is denoted by gx and gy, and you want to the robot get the goal waypoint following an arc, instead of turn off that direction and go straight. So we draw an arc, but in fact this arc is not unique. We can draw other arcs that meet the car and the goal waypoint. So how do we make it unique? We should constrain the center of the arc to be on the y-axis of the vehicle. So if we put the center here, we'll have the radius of the arc, and basically this is the gy coordinate, or the absolute value of gy, and this is gx coordinate, or the absolute value of gx. So now let's see some quick math to solve this value. These two equations are obvious. R is the absolute value of gy plus d, and d squared plus gx squared is equal to the radius squared. Then just substitute out d as r minus absolute value of gy, and then solve the equation looking for the value of the radius. The curvature is the inverse of the radius, so the steering angle should be proportional to the curvature of the arc. Okay, once we know how to calculate the steering angle, how can we follow the waypoints? Well, every time we have a new pose of the car, we have to get the closest waypoint to the vehicle, which is in the look-ahead distance range, and then go up toward that waypoint using the calculated steering angle, and once the car reaches the goal waypoint, localize itself to find the new pose and repeat. As we mentioned before, the look-ahead distance is a parameter of this algorithm. In this figure, we can see an interpretation for a smaller value for L and large values of this parameter. A smaller L leads to more aggressive maneuvering to follow a closed arc. But closer arcs can work against the limit of car dynamics. On the other hand, a larger L leads to a smoother trajectory but with higher tracking errors, which can lead to close approaches to obstacles. To finish, I would like to show an implementation of purposed algorithm in our all-to-race simulator. Here you can see a sequence of red points. They are the waypoint list painted in the path. Here. And the blue line painted in front of the car is the steering angle of the car. We can see how the car follows the waypoints in this track. Okay, thanks for watching.